So now that you know the intro to trigonometry, now what to do is to show you some different example calculations given certain right-angled triangles. We're going to go through sine, cosine and tangent. Now apologies here, for some reason we've got glaring glare pants over here, so I've tried to draw a bit here, but just imagine that that is still quite a bit of triangle up there. It hasn't sort of disappeared into the ether, as it were. Okay, so I've got these particular functions. When you're doing these examples of trigonometry, it is always worthwhile to label the different sides. So for example, I've got this particular triangle here. The 30 degrees is what it says over here. So the first thing I would label is I would label the side opposite to that angle, which is here. So that's the opposite. And then I would then look at, okay, the side next to the angle, well that's the adjacent. I use the three letters for short there. And then finally, this is the hypotenuse. Similarly over here as well. So I've got the angle here, that's 25 degrees. The side opposite that is the opposite. The side next to it is the adjacent. And this side here is the hypotenuse. So there we are. That is the three different sides that we've got there. Now, well, this will help us remember which formula we use for which. So with this first one, I have got the sides that I've got information about, or I need to find, is the opposite. So I need to find the opposite. I've been given information about a hypotenuse. So which of our formulas involve opposites and hypotenuse? So remember our chant soccer talk. So a sine is equal to opposite over hypotenuse. So sine 30 is equal to opposite over hypotenuse. So what I'll do is I'll fill in the details. Now hopefully you might remember that a sine 30 degrees is always equal to a half, or 0.5. If you don't remember that, you can punch that into your calculator. I'm not judging. So sine 30 is 0.5. It's equal to the opposite, which is here x, over 30. Now, in order to go and complete this, in order to find out what x is, what I'll need to do, and I'll use a different colour marker here, I'll use a bit of orange here, multiply both sides by 30. Why do I do that? Because if I multiply 30 here, those will cancel out. So that means my final answer here, x is equal to 30 times 0.5. 30 times, or half of 30. So when someone says a half of 30, that's the same as saying a half times 30. Of is another way of saying times. So a half of 30, or 30 times 0.5, will of course be 15. Now this was in centimetres, so our answer must be in centimetres. So this side is 15 centimetres. There we go. Well, okay, now to work out the other triangle. So I've got here, so I'm going to go sine 25 is equal to 10 over x, because sine is opposite over hypotenuse. Opposite over hypotenuse. So now, this is slightly different. So if I multiply on both sides, I can cancel those out. And what I can do is, when I get a marker that works, as opposed to none of these, x times sine 25 is equal to 10. Now, whenever you're working this out, I need to get x's on their own. So what I'm going to do is divide both sides by sine 25. Because those will cancel out, and x will just be equal to 10 over sine, equals 10 over sine 25. And what you just need to do is put that in a calculator. Now, depending on your calculator, you might need to put some brackets around things, but hopefully not. Hopefully you can just type in 10 divided by sine 25. Make sure that your calculator is in degrees, so it should have a D or deg or something like that. The answer here is 23. Let's put it to one decimal place. So it says 23.662 for one decimal place. I'm going to round up to 23.7. Now, it was in kilometres, so our answer must be in kilometres. I wonder if you've noticed when I've worked out how I could get from this step to this step very quickly. You know how I multiplied x's on both sides and I cancelled things out? I don't know if you've noticed, but when I did sine 25 equals 10 over x, the final answer here, all I did was swap the sine 25 and the x around. So in other words, what I could have done, if I the joys of time travel. What we can do here is actually just swap those two around, and my final answer is just x equals 10 over sine 25. And that would get me my answer that I had before. Exactly the same way. I've just saved a bunch of working out. So that was 23.7. Done. Because remember, at year 12, in a calculator-enabled exam, if I wanted 2 marks worth for a question, there's 1 mark, final answer is 2 marks. So I don't have to do pages upon pages of working out. I could just do it like that. Alright, so that's science. What about my next step? Here we go. So again, I'm going to label this. Okay, the side next to it here is the adjacent hypotenuse, opposite. So adjacent, hypotenuse, and opposite. So in this particular example, unlike the other ones, I'm now dealing with adjacents and hypotenuses. So this means that we're dealing with cosine. So I know that cosine 45 is equal to adjacent over hypotenuse. So therefore, this is equal to adjacent is x over 26.2. So all I need to do now is to multiply on both sides by 26.2. So I'm going to multiply 26.2 times by 26.2. And then my final answer of x will be 26.2 times cos 45. And who needs to have a brain when you've got a calculator to do it for you? So 26.2 times by cosine 45. And I get here 18 point, we're going to do one decimal place, 5. And this was in millimetres, so my final answer must be in millimetres. And there's our final answer. For the other triangle here, what we've got here, what we'll have is, so cos of 23 is equal to adjacent over hypotenuse, so 16.8 over x. And remember our little sneaky trick, I can just swap these two around. X is equal to 16.8 divided by cos 23. And then we pop into our calculator here. 16.8 divided by cos 23. And again, we get 18.25, which would be 18.3. And this was in meters, so this also has to be in meters as well. There we go. The last one we're going to deal with, obviously, will be tangents. Again, going to label this. This is the opposite, adjacent, and this side is the opposite. One next to it is adjacent. So I'm using opposites and adjacents. That's the TOA, or tan is equal to opposite over adjacent. So, tan of 60 degrees is equal to the opposite x here over 8. So therefore times 8 by both sides, so those will cancel out. X is equal to 8 times tan 60. And then what we can do is pop that into a calculator. Times tan 60. And I get 13 point, it says 856, so I'm going to round it up to 813.9, and this is in centimetres. There we go. The last triangle over here we've got is tan 53, opposite over adjacent, so 0.16 over x. So remember, we can swap just these two around. X is equal to 0.16 over tan 53. So 0.16 divided by tan 53. So it's equal to 0.12, I'm going to put here, kilometres. Now I've got here, it's in kilometres. My suggestion would be you might want to have this in a much easier and friendlier way. I'd actually put this in metres, even though that is in kilometres. My final answer could be expressed as 120, and in fact it would be 120.6 metres, because according to my decimal places, so that would be perfectly fine. And there we are. That is how you can use trigonometry to go and calculate that kind of thing. Now, go away.